We've reached day 32 in our series on real analysis, and today we're going to talk about derivatives. Now, derivatives are one of the first things you see in a calculus class, but one of the last things that you see in a real analysis class. Now, luckily, all of my students, and probably most viewers who have made it this deep in this series, are familiar with the notion of a derivative, which is what this definition gives us up here. And you probably know that what it's measuring is the slope of the tangent line to a function if that tangent line exists. Now, this function up here does not have a tangent line at 0 because there's no good linear approximation of the function there. And this shows that just because a function is continuous, it does not mean that it's differentiable or that it has a derivative. However, the converse of that is true. If you have a function that is differentiable, meaning it has a tangent line at a point, then that function has to be continuous at that point. That's one of the proofs we did today in class. It's not too bad, but it does require some care in really thinking about what you can do with this limit definition up here. Talk a little bit about applications of derivatives in the next video, including a generalization of the extreme value theorem. But for now, I want to just pose some questions. Here are some random functions I've put up here, and I wonder which of these you think are differentiable. And if you think they have a derivative, well, do you think that derivative is itself continuous? And do you think that that derivative is differentiable? In other words, do you think there's a second derivative? And then same question with third derivative and things like that. These are the sorts of things that I'm going to be helping my students work with as we come up with lots of cool examples in this class. Put your thoughts in the comments. I'm curious to know what you think about these functions. Pay special attention to what happens at 0.